Hello, everybody. I'm back with another problem related to basically topic of uh, particle equilibrium, subject of statics or physics. Very really trivial problem, and want to take a look at this problem. So let's get it started. Just close that picture of mine. So here you have a series of, it says 5 cords that are holding this basically load referred to as a pipe here. So the mass of the pipe, as you could see here, is 30 kilograms, which we can then convert it to newtons by multiplying it by 9.81 and get the weight. So let's say roughly that's 294. It's 294.3. We'll just round it to 294. So kilograms times meters per second square becomes 294 newtons. So basically, we have to look at the free body diagram of a bunch of points. So our objective, obviously, is to determine the force in each cord for the system to be in equilibrium. So if we start with the obvious one here, look at the free body diagram of point H. Clearly, the weight is 294, right? The weight of the pipe. Therefore, the tension in this cord, which you can call it HA or AH, doesn't make any difference. By inspection has to be 294 newtons. So that's obvious. Then the next thing I want to do, so this was point H, basically, free body diagram of H. So the next point I want to look at is point A. So if you look at point A, what do we have here? We have clearly the tension in cord AH, which is, we just determined that that's the 294, which is again the weight of the pipe, right? Then the tension in cord AE and the tension in cord AB, which forms an angle of 60 degrees with respect to what? Horizontal. So another simple situation where you just apply the equilibrium equation in 2D, which is basically two equations. You can apply the equation in the X and Y, pick a direction. So notice that if you first apply our equation in the Y direction and pick this to be positive, the Y component of this tension AB happens to be what? TAB sine 60, right? So TAB sine 60 in the positive direction, then you have the weight going in the negative direction. You have just one unknown here, so you can solve for TAB. TAB roughly, based on the 294, it's about 340 newtons. So that's the tension AB. Now you can go ahead and use this equation. So do the equation in the X direction, right? And notice that if you pick this to be positive, direction to the right, the X component of this guy, the tension AB, is TAB cosine 60 now, right? And that has to be the same as what? TAE, because we are balancing the forces in the X direction. So minus TAB cosine 60 plus TAE equals 0. Therefore, TAE becomes minus TAB, I'm sorry, positive TAB because you took it to the other side, cosine 60, right? So TAB is 340, roughly. Cosine 60 is 0.5. So TAE should be about 170 newtons. So we are almost there. So we got this tension already. We got this tension and tension AB. So finally, we look at the free body diagram of point B to finish up. So what do we have for point B? We have obviously the tension in AB or BA is already calculated, and that's 340. So I'll put that as a known, like that. 340, right? We know the angle is 60 degrees, right? Same as this angle here. And finally, you have tension BD, which is, it's defined as by its slope of 3/4, 3, 4, 5 triangle, and then of course tension BC, that is going horizontal. One thing I forgot to mention, which just goes without saying actually, is that for free body diagram of a two-dimensional system in equilibrium, you cannot have more than two unknowns. You see here we had two unknowns, tension AB and tension AE. So now here we have what? Two unknowns again, tension BD and tension BC, because you only limited to what? Two equations, right? So let's go ahead now, apply again the sum of the forces in X and Y. Again, it makes sense to start with the equation in the Y direction and balance components in the Y direction, because this guy is only in the X direction, so it's not going to appear as an unknown. So you see the Y component of tension BD is 3/5 of TBD, kind of saying TBD times sine of this angle, right? So 3/5 of TBD going in the positive direction. And then what's the Y component of this guy? It's pointing down, 340. 340 cosine 60 would be the X component. We need the sine 60, right? So go ahead and solve for TBD. Comes out to be roughly 490 newtons. And now you can go ahead and do the X component. Balance the forces in the X direction, pick a direction for yourself. So what do you have? Obviously, you have the tension BC entirely in the X direction going to the negative side. And then you have the X component of this guy, the 340, which is positive 340 cosine 60 clearly, since we use the sine 60 here, right? And the X component of TBD, as you could see, is also in the positive, but TBD, we've already calculated that. We're going to plug that in here. And that's times 4/5, kind of like saying cosine of this angle again, right? And remember, TBD is 490. So plug that in. So put 490 here and do the math. And TBC comes out to be about 562 newtons. Okay, very simple problem, guys, as you can see. Just a few steps. Conversion has to be done from kilograms to newtons, right? And then just make sure that for every free body diagram of every point, you don't have more than two unknowns, which was the case here. So again, thank you for watching my channel, and I always come back with new problems on different topics, different subjects. So I appreciate if you like the video and join my channel. So I'll see you soon. Thank you again, and have a good day.